Hi and Assalamualaikum. Welcome to our video presentation MA3183.
This is our group member.
For the introduction, this slide is in this chapter we focus on function given by formula. The derivative of such function are then also given by formulas. In chapter 2, we use information about the derivative of a function to recover the function itself. Now we go from the function to its derivative. We develop the rules for the differentiating function, computing the formula for its derivative from the formula for the function. Then we use differentiation to investigate the properties of function, especially their extreme value. Finally, we examine a powerful method for solving equation that depends on being able to find a formula for a derivative body x. Question 1. Explain the meaning of differentiation and what are the techniques of differentiation. Differentiation is a concept that is in calculus and that involves the finding of the rates of change of a function. It tells to us how it is that one quantity change with regard to another one. For example, if y equals to fx, then dy dx shows how y change when x change. It's used to find slope of curve. And technique of differentiation, we have a five technique. We have a derivative of constant, linear, and power function. We have a product rule, quotient rule, chain rule, and implicit differentiation. And for a constant, the f prime x or dy dx equals to 0. And the linear, f prime x or dy dx equals to a. The power function, f prime x or dy dx and x power of n minus 1. And for the product rule, you must remember that the theorem is the dy over dx equals to uv prime plus vu prime. So for this example, we have a function f x equals to x squared and sine x. So the derivative is f prime x equals to 2x sine x plus x squared cos x. So for the quotient rule, we have a theorem dy over dx equal to vu prime minus uv prime divided by v square. So for this example, we have a function f x equals to x square divided by x plus 1. So the derivative is f prime x equals to 2x x plus 1 minus with x square divided by x plus 1 square. Chain rule, the function is fx equals to sine x square. So the derivative is f prime x equals to cos x square 2x. And the implicit differentiation, the equation is x square plus y square equals to 25. So we the implicit derivative is 2x plus 2y on dy dx equals to 0. And we solve the equation, and the answer is dy over dx equals to negative x over y.
Hello, my name is Alif and I will be doing the question 2. So find dy over dx for the following function. So let's solve for a. For a, there is a product of two different functions, which is 3x squared and secant x plus 2. So in this condition, we must use the product rule formula, which is uv prime plus vu prime. And then we choose which one is u and v. For me, the u is 3x squared and v is secant x plus 2. And then differentiate the u and v. The u prime becomes 6x and the v prime is secant x plus 2 tangent x plus 2 1. And then substitute the value in the formula. and we get 3x squared secant x plus 2 tangent x plus 2 plus secant x plus 2 6x, and then simplify it and get the answer 3x squared secant x plus 2 tangent x plus 2 plus 6x secant x plus 2. So let's solve for the b. For b, there is a division of two different functions, which is 4x plus 2 over cos x. And then for this condition, we must use the quotient rule formula, which is vu prime minus uv prime over v squared. And then choose which of the function is u and v. For me, the u is 4x plus 2, the v is cos x. Differentiate the u and v, and we get u prime 4, v prime negative sine x 1. And then substitute the value into the formula. It will become cos x cos x 4 minus 4x plus 2 negative sine x over cos x squared, and then simplify it and we get the answer 4 cos x plus 4x plus 2 sine over cos squared x. So that's all for me. Thank you.
Question 3. We are given the equation y times n of 3x minus e to the power of 2x plus 1 minus tan of 4y equals 0. We are asked to find dy dx using implicit differentiation. Step 1. Differentiate, differentiate both sides with respect to x. Let's go term by term. First term, y multiplied by n 3x. Since this is a product of y and n 3x, we apply the product rule. The derivative is dy dx times n 3x plus y times the derivative of n 3x. Now the derivative of n 3x is 1 over x. So the whole derivative becomes dy dx times n 3x plus y over x. Second term, negative e to the power of 2x plus 1. Using the chain rule, this becomes negative 2 times e to the power of 2x plus 1. Third term, negative tan of 4y. Again, apply the chain rule. The derivative of tan 4y is sec square of 4y times to the derivative of 4y, which is 4 divided x. So this term becomes negative 4 sec square for y times divided x. Step 2, combine all derivatives into one equation. Dy dx times n 3x plus y over x minus 2e to the power of 2x plus 1 minus 4 sec square 4 times dy dx equals 0. Step 3, group dy dx term. Move all dy dx term to one side. Dy dx times n 3x minus 4 sec square 4y times dy dx equal 2e to the power of 2x plus 1 minus y over x. Now factor dy dx. Dy dx times open bracket n 3x minus 4 sec square 4y close bracket equal 2e to the power of 2x plus 1 minus y over x. Step 4, solve for dy dx, divide both sides. Dy dx equal 2e to the power of 2x plus 1 minus y over x all over n 3x minus 4 sec square 4y. Final answer, it is a derivative using implicit differentiation. That's all. Thank you.
Hi, my name is Waino Khalida and I will be doing the question 4. The question asks us to use linear approximation to estimate the value of 4 root 80.99 minus 2 over square root 80.99 correct to 3 decimal places. So this is my calculation for the question. First, I let fx, which x is equal to 80.99, and the chosen value is 81, which is the nearest number for 80.99. So the Dirac delta I get is negative 0.01. So first step is I let fx, which I get 4 root of x minus 2 over square root of x, and to simplify it I get x power of 1 over 4 minus 2x power of negative 1 over 2, and I differentiate it to get the f prime x. I get 1 over 4x power of negative 3 over 4 plus x power of negative 3 over 2. So I use the differential formula to get the answer, and the formula for the differential formula is f x naught plus Dirac delta equal to f x naught plus f prime x naught Dirac delta. We can so I just substitute the value into the equation that we get from earlier, and after all the calculation, I get the answer is 2.789. In the conclusion, I will explain that this chapter helped me understand how to find the derivative of a function. It showed me how to solve different types of problem, like finding how fast something changes or when a graph goes up or down. Differentiation is useful for answering many questions in both math and science.